The public sees artificial intelligence through a glowing screen. A model answers a question, writes a paragraph, or identifies an object in a photograph. The exchange feels weightless. It appears to belong to the world of pure information, where clever code floats above the physical limits that govern ordinary industry. That appearance is false. Artificial intelligence begins in a factory. Before a model can answer a single prompt, a semiconductor plant must produce the chips capable of training it. Those chips must then be installed inside enormous computing facilities. The facilities require power. The power must arrive continuously. A failure anywhere in that chain can reduce an ambitious national AI program to a collection of press releases and unfinished procurement contracts. This is why the contest over artificial intelligence will eventually become an industrial contest. Model design matters, software talent matters, yet neither can substitute for the ability to manufacture the machines on which the software depends. A nation that possesses brilliant researchers but lacks advanced chip production is in a precarious position. Its intelligence may be domestic, while its physical capability remains foreign. That nation can build applications, it can create new training methods, it can even produce a model that attracts global attention. Yet every major expansion depends upon factories beyond its control. Dependence of this kind is tolerable during peace. It becomes dangerous during conflict. Suppose a confrontation interrupts access to advanced processors. The nation with domestic fabrication can continue producing replacement hardware. The dependent nation must ration what it already owns. Training schedules grow longer. Military programs compete with commercial firms for the same limited supply. Damaged systems become harder to replace. A software advantage begins to decay because the physical equipment underneath it cannot be renewed. This is where much of the current discussion goes astray. Commentators treat artificial intelligence as though it were a contest between research laboratories. They compare benchmark results. They argue over which model reasons more accurately. These comparisons matter, but they describe the visible edge of a much larger structure. The deeper contest concerns production. A state that can manufacture advanced chips at scale possesses something more durable than a temporary lead in model performance. It possesses the means to reproduce that lead. It can expand computing capacity without waiting for foreign permission. It can direct processors toward military planning when war demands it. It can replace damaged infrastructure after attack. The power lies in repetition. Industrial power has always worked this way. A weapon matters because a state can build another one. A machine becomes strategically meaningful when it can be produced in quantity. The same rule applies to artificial intelligence. A single advanced model may amaze the public. National power begins when the model can be trained again, deployed widely, and supported during prolonged pressure. Factories decide whether that can happen. The semiconductor plant is therefore becoming one of the central fortresses of modern power. It may lack walls in the traditional sense. Its machinery may appear delicate rather than martial, yet the strategic function is unmistakable. The plant determines which states can create the processors required for advanced computation. This makes fabrication capacity a target. An adversary does not need to defeat every model. It can attack the means by which models are produced and sustained. Export controls can restrict access to manufacturing equipment. Cyber operations can disrupt production. A blockade can interrupt the movement of specialized materials. The resulting damage may appear commercial at first, but its consequences reach directly into military capability. An AI system used for intelligence analysis depends on the same industrial base as a commercial model. Its purpose may be national defense, but its body is still made in a factory. If the factory lies abroad, then the state has placed part of its defense policy inside another country's political decisions. This is the problem of technological sovereignty in its clearest form. Sovereignty requires control over systems that cannot be replaced during crisis. A nation may purchase foreign technology during ordinary times. It cannot assume that the same access will remain open when its interests diverge from those of the supplier. Markets hide this danger because markets reward immediate cost. A foreign chip may be cheaper. An overseas plant may offer greater scale. Corporate executives can defend the arrangement with a spreadsheet. The spreadsheet rarely contains a row for national humiliation. States must think beyond the next quarter. They must ask whether the productive base can survive pressure. They must ask whether skilled workers exist to operate it. They must ask whether essential machinery can be repaired without foreign approval. These questions sound mundane beside the glamour of artificial intelligence, which is precisely why they are often ignored. Power usually enters through the warehouse door while the public watches the stage. The United States has learned this lesson unevenly. American firms remain central to the design of advanced processors, yet design alone does not guarantee command over production. A blueprint can be drawn in California, while the decisive manufacturing occurs thousands of miles away. The intellectual property may be American, but the strategic vulnerability remains. That distinction matters. Ownership of a design gives a company legal control. Ownership of fabrication gives a nation physical control. During normal commerce, the two can operate together. During war, the separation becomes severe. A government cannot deploy a patent into battle. It needs working chips. This is why industrial policy has returned to the center of national strategy. The return is overdue. For decades, many Western leaders treated manufacturing as an old economic function that could be moved abroad without serious political cost. They believed that high-value design would remain at home, while lower-value production could occur elsewhere. Artificial intelligence exposes the weakness in that doctrine. Production is not a lower stage of technological power. Production is the point at which an idea becomes usable force. A state that cannot build advanced processors does not fully command artificial intelligence. It rents access to it. The same principle applies to the facilities that house those processors. Large AI systems require enormous quantities of electricity. They also require cooling equipment capable of keeping concentrated computing hardware within safe operating limits. These facilities are industrial installations, even when companies describe them with the misty language of the cloud. There is no cloud. There is a building drawing power from a grid. This fact ties artificial intelligence to energy policy. A nation may possess researchers and capital, yet still fail to expand computing capacity because its electrical system cannot support the demand. The model becomes hostage to transmission lines. The grand strategy of a state can be slowed by a transformer shortage, which is the sort of joke history enjoys telling to people who think software has escaped matter. Energy abundance will therefore shape AI power. States that can supply reliable electricity to large computing facilities will enjoy a structural advantage. Those that restrict generation while demanding greater computing capacity will discover that political slogans produce very little power. The factory and the power plant belong to the same strategic system. Artificial intelligence joins them. This changes the meaning of technological leadership. Leadership cannot be measured by model quality alone. A country may possess the best model for 6 months. That lead may disappear when a rival trains a larger system. A durable advantage comes from the capacity to produce chips, expand computing facilities, and sustain the electrical burden over time. The factory turns temporary discovery into lasting power. This is why the AI arms race will resemble older contests more than its promoters admit. States will compete over industrial depth. They will protect supply routes. They will train skilled workers whose knowledge cannot be summoned by decree. The decisive advantage will belong to the nation that can continue building after the first shock. War reveals the difference between possession and capacity. A country may possess a stockpile of advanced processors. That stockpile is finite. Every damaged system reduces it. Every new military requirement consumes it. Without domestic production, the stockpile becomes a clock counting downward. A country with manufacturing capacity faces a different calculation. Losses still matter, but they can be replaced. New systems can be built. Existing systems can be upgraded. Industrial depth gives political leaders room to act because they are not forced to conserve every machine as though it were the last lantern in a storm. The strategic question is therefore simple. Can the nation reproduce the technology on which it depends? If the answer is no, then the nation does not command that technology. It enjoys access under favorable conditions. Those conditions can change. Artificial intelligence will remain one of the most powerful instruments of the coming age. It will shape military planning. It will alter intelligence work. It will influence how governments interpret events. Yet its power will remain attached to physical systems that must be built somewhere. The states that understand this will treat semiconductor plants as strategic assets. They will secure the energy required to run them. They will cultivate the skilled labor needed to keep them operating. Their rivals will continue speaking about software as though code were a ghost. History is unkind to nations that mistake a ghost for an army. The winner of the AI arms race will possess more than the smartest model. It will possess the means to build the next model after supply chains fracture and political trust disappears. That victory will begin under factory lights.